Hello everyone, my name is Tahmine and I'm interested in hyperparameter optimization for machine learning model and I wanna share something in this video with you. This video is about hyperparameter optimization and I wanna explain about what is a hyperparameter and why they are important, and also I wanna speak about some methods to optimize hyperparameter. One of them is Bayesian optimization, and I also speak about Gaussian process, acquisition function, and other methods. But I think others will be in another video. What is exactly hyperparameter? Hyperparameter is a parameter in machine learning model. In each machine learning model, we have two groups of parameter. A group of parameter which are normal, their value can be trained during training process and from dataset. But another group of parameter are hyperparameter, and their value cannot be estimated from dataset and learned during learning process. They are hyperparameter. Why they are important? Because they can change, improve our model. Because for different hyperparameter we face with different models, and so we have to choose optimal value for hyperparameter in order to have a better model. Here I have also some examples of what are hyperparameter, like learning rate in a training neural network. Learning rate tells us with which speed we should move in direction of gradient, and if it is too small, it is usual that we stuck in a local area, and if it is too large, it is also possible that we stuck we skip from our optimal value, and so we have to choose its optimal value. Another example is k in k nearest neighbors, and k nearest neighbors is a supervised machine learning model, and it is good for classification and regression. And the idea is so that we want, for example, choose to which group of data that we have already belongs our new point, and we should check the k nearest neighbors to this new data point. And for example, if k is equal to 4, we should check the 4 nearest neighbors, and so on and so forth. And so we have to choose its optimal value. And other examples are also number of hidden layer in a neural network, number of activation units in each layer in neural network, and number of iteration in a training of neural network, batch size, and also lots of other examples. And so now we know what is hyperparameter and why they are important to be optimized. Also, we have different methods to optimize the value of a hyperparameter. Manual methods, that is okay if our model is too small and we are aware of what hyperparameter are the most important ones, and what is the relationship or correlation between hyperparameter and our output, and so we can choose their optimal value and start our training process. But usually, when our model is huge and our dataset is large, it is too expensive to choose a hyperparameter manually, and so we have to use optimizations methods. And we have also different optimization methods, but one of them is Bayesian optimization. And about that, I want to explain. But now I want to introduce you surrogate model. What is surrogate model? Surrogate model uses a surrogate or approximation for our objective function, and so this model can estimate or make an approximation for objective function. It means instead of solving our true and main solution problem, we can solve another problem which is easier. And Bayesian optimization puts surrogate optimization or surrogate model in a probabilistic framework by definition a probability distribution as our objective function. Now we have different surrogate model which uses Bayesian optimization like Gaussian processes, three-person estimators, random forests. And I want now speak about Gaussian process, but before that I want also explain about Bayesian optimization. So, what is surrogate model? Surrogate model makes an approximation for our true objective function, and we build our surrogate probability model and for our objective function, and we solve this model and obtain our hyperparameter and apply this hyperparameter to our true objective function. And after that, we can update our surrogate model and um, repeat these steps until time is out or we meet the upper bound for our iteration. But what is look like the objective function in hyperparameter optimization? We should be aware that objective function is here different than objective function in our machine learning model, and it is like a function that we have a score for each hyperparameter. Although this objective function seems to be really simple, when our data point is a data set is too large, this function is not also too easy, and calculating this function is too expensive. And so we have to use surrogate model. Um, what is here Gaussian process? But before starting Gaussian process, which is a surrogate model, which uses Bayesian optimization, we should know what is Bayesian optimization. Bayesian optimization is based on Bayes' theorem, and it is really good method to optimize a kind of optimization problem. In them, we face a objective function which is unknown or calculating its derivatives is too expensive, or we do not have a closed form of our objective function. It is really efficient for this kind of probability optimization problem, and you should know how important this optimization method is. But about Bayes theorem, it is like that if we have two groups of events like A and M, and distribution over M is not zero, so we have this prior distribution, which is probability over E, and we want to calculate probability over M. Uh, it calls it is called posterior distribution, and it is likelihood of data, and it is prior distribution, and it is uh, marginalization, marginal likelihood. And now about Gaussian process. Um, Gaussian process, we define a Gaussian distribution as a prior distribution, and so as we know, each Gaussian distribution is defined by a mean and covariance function. And mean is a function with this domain, and also K is a matrix, is covariance matrix with this definition. And all the elements on a main diagonal are equal to 1, and other elements can be calculated with this relation, with this equation. Also, for simplicity, we assume that m is equal to 0, and so the main challenge in the Gaussian process is how to choose our covariance function in order to so that our prior distribution explain our data more precisely. And so we have our prior distribution, and we want to choose our covariance function and calculate our posterior distribution. In next slide, I want to show how it's look like. If we have t sample points and we want to know about next sample point, which is ft plus 1, f1 to t plus 1 is a t plus 1 dimensional normal distribution, and it has this distribution between equal to 0 and this covariance function, and f1 to ft, which we see here, is like this vector, and k seems like this matrix. And ft plus 1 also is one dimensional normal distribution and has this distribution. As we see here, we do not have a scalar value for f instead of and we have a probability distribution of all admissible value over f, which fits our data. And so if our dataset is large enough, we can obtain an approximation of our function. And I think it's enough for now. And I will speak further about hyperparameter optimization in next videos.